Okay, let's print a benchy out of resin on a standard FDM printer.
This video is sponsored by Referpoint with their new range 3D scanner. FDM resin printing. The art of printing UV curable resin on a regular FDM printer. Even Hackaday, after featuring this 2 times, didn't have an idea why we are doing this. I believe that this could be revolutionary. This may sound exaggerated, but being able to print liquids and pastes brings some interesting possibilities. I want to get continuous fiber printing working on an affordable printer by infusing the fiber with resin, but first we are going to improve on what we have done in our previous attempt, which was already pretty successful.
We received a bunch of comments in our last video, which helped shaping the mission for this video. I focused on the light source, on the nozzle, and I'm going to focus on the resin itself. First, let's take a look at the light source. In the very first attempt, I found out that it's possible to cure resin using these standard low power lasers. And the nice thing about these laser units is that they are very easy to control. You can connect them to your 3D printer and they work. Initially I tried optical fibers to get the light to where I wanted it to go, but I screwed that up a little. I still think that it would be possible to use optical fibers, but it's so much fiddling, so much work, that I decided to ditch that plan, and lasers are already quite good at pointing light somewhere, so therefore I just kept using these lasers. This came with the drawback that the resin started curing at the tip of the nozzle.
How do I prevent that?
And I worked my way around that problem by blocking the light here at the center. And that works, but we are losing efficiency. We are blocking a significant part of the light. But what instead of blocking the light, we bend the light. After a quick search, I quickly found these hexagon lenses. Hexagon lenses are conically shaped lenses, and if you put them in front of a laser, then they should cast a ring. That looks like the perfect solution for this problem. So I started making my own hexagon lenses. My YouTube colleague Stefan from CNC Kitchen made a very interesting video in which he showed how you can make transparent parts out of PETG. And I've got a bunch of these lenses here. I tried improving the parameters and eventually ended up with something that I was quite happy with. I sanded it down and I polished it. It looks very transparent. It already looks good enough to at least try if it does anything. So I mounted this to the laser, to one of these lasers, checked the difference between them, and I was quite disappointed because the one blocking the light was significantly better. And then I realized that this literally is the perfect shape for conical slicing. The good news is that I now know how I have to do conical slicing, but the bad news is that the print itself completely sucked. I put too much heat into it, the part was just too small. There's still one thing that I can do. I have this raw material, this raw acrylic, and this is very transparent, but I have to use a lathe to make this. I still think it's fun to actually make hexagon lenses, but I came to the realization that my time is better spent improving the other problems we have with this FDM resin printing idea. I started this idea by using the lure lock system as a nozzle, which makes sense because lure lock is often used for applying pastes and liquids, and you can buy these nozzles with several diameters, shapes, lengths, etc. But I ran into the issue that the tip of the lure lock system is pretty flimsy. Okay, editing John here. I was looking for pictures of lure lock systems and I just found out about these. It looks like there is a version of a lure lock system that isn't that flimsy. This could still be an interesting solution for another application, so it's good to know that these exist. Okay, let's continue with the video. So I ended up using a standard nozzle. Just look at it. That worked. It was way sturdier and it just plowed its way through, but there were some drawbacks. First drawback is that it's quite hard to form a seal between the tube and the nozzle. Second drawback is that the resin tends to stick to the nozzle, and I think that's because the angle between the nozzle and the print surface is quite shallow. I decided to design my own nozzle and I'm pretty proud of it. It's just which should eliminate all of these issues, and it looks cool as well. here on my screen. This is about the size of a standard nozzle, so that's it's pretty small. With this nozzle, the resin should flow from the side through this cone here. So let me make this transparent. So it should flow through this cone, through this tube. This is a brass tube which is pressed in. Funny thing is that in a way earlier video I said this.
I came up with a great idea to do with these brass tubes, which is totally unrelated to this project. If I didn't start this project, I wouldn't come up with this idea, and that will be an idea for a future video.
Okay, I didn't come up with this exact idea, but I had the idea to use these brass tubes to make a nozzle. And here we are, so that's pretty dope. If you have an idea and you will fail, then or you learn new stuff or you come up with new ideas. These two O-rings, they form the seal, and the counterpart, that's this one, the resin flows through here and should flow between these two O-rings. If this works, then I think that this is pretty dope. If this works, then I also think that this place here between those two O-rings could form a mixing chamber. So if I've got a second tube on the side here, then we can mix two resins, one rigid and one flexible resin. So and the mixing happens within the nozzle. And to make it even cooler, I think it's also possible to make a hole here at the top and place a fiber in there, the continuous fiber, so push the continuous fiber through and fuse that with resin, and we can get continuous fiber printing to work. And this extruder that I have made already a couple of videos ago is capable of pushing fibers, so I can just mount this nozzle here. You will get the idea. I think that this is going to be awesome. The only thing I'm a bit afraid of is that it starts clogging inside of the nozzle because everything is so small. I also think that this nozzle can be bigger. I've printed everything out of resin on the Anycubic Photon D2. I'm pleasantly surprised by how well it works. I think that this is the perfect prototyping printer. It prints very fast and accurate. Because I'm so happy with this printer and resin looks very good, and I already wanted to print the non-pulsating peristaltic pump which is used in this whole project out of resin, I decided to make this.
This video is sponsored by RevoPoint. They just introduced a new 3D scanner, the RevoPoint Range. This is the world's first affordable large object scanner with a single capture range of 360mm by 650mm at a distance of 600mm. This makes the range a powerful tool for scanning large objects like cars, furniture and industrial parts. the range is even compatible with smartphones, which ensures total handheld scanning freedom for these large objects. The premium package includes a large turntable with a maximum load of 200 kilos. This is ideal for scanning people since you don't have to walk around your subject. The invisible infrared is safe for the eye and the range has improved texture mapping for lifelike scans. I often reverse engineer things, so I can design my own replacement parts or add additional functionality. With the range I can make a quick scan of the relevant areas, do some reference measurements, and I can design my way around it. For me, this is a necessary tool which saves me a lot of time. I don't have to iterate as much and I can use the scan as reference to get a good idea about the end result. There's a lot to discover with 3D scanning, and Referpoint just launched a very successful Kickstarter with over 3,500 backers. Referpoint is no stranger to Kickstarter with over $8.2 million raised from successful Kickstarter projects. It's Referpoint's dream to make 3D scanning accessible to everybody by drastically lowering costs and learning curve to mastering 3D scanning. You can get your range now from Kickstarter with a guaranteed delivery. Check the link in the description of this video to find out more.
Okay, I attached the pump to our experimental research platform and the files of this thing are available on the website. However, the version on the website will not contain these super fancy inserts. They will contain these standard M3 nuts, which are way easier to get. Our very first attempt, we used regular resin, but failed because it formed drops. Once the nozzle didn't come in contact with the part being printed, a drop was formed, was placed somewhere else and the print failed. So on our second attempt I made custom resin and added these glass bubbles. We got some very interesting results and we managed to print a interesting looking benchy. The major drawback of using glass bubbles is that they started to float. On that video I received several comments suggesting using fumed silica or aerosol. So I made custom resin again with the supplies from 3D Resins. By the way, thanks 3D Resins for your supplies and for supporting this project. This time, instead of black, I added a blue dye because I think that looks cool. And then I added the fumed silica, this time wearing a good respirator. But this started clumping and that's a big issue. After mixing it thoroughly, I pulled a vacuum this time to remove all air. It started foaming quite a bit, so I think we've removed quite a lot of air. And now I ended up with something quite interesting. It looks way different than the stuff of last time. Well, it looks very blue, but also the consistency is, well, this is almost like pudding. It's just a gel instead of a paste. And it also looks like it's transparent, which is freaking awesome. It's quite thick, so hopefully not too thick. But we will find out. Okay, fingers crossed that this nozzle works. Resin is coming out of the nozzle. Nice. The fumed silica, you don't see the particles. It's just like it has dissolved into the resin, forming this gel. People suggesting using fumed silica. Thanks, I think we're onto something here. Okay, this is pretty wild. I haven't done anything yet, and because of the pressure inside of the tube, it continued oozing. And it's already capable of keeping its own weight without even curing it, so this looks very promising. Okay, let's start printing that rocket we have also printed in the last video. Maybe it's too thick. It looks like the flow is starting to get going. Okay, let's try again. Okay, well, it is cured, so that's nice. There's a lot of pressure in here. Before everything explodes and everything is covered in resin, I'm going to stop the print. Also a quick shout out to Wham Bam for these silicone mats, because this is ideal especially for something like this note-to-self cup holder. This tube is now filled with resin or paste or whatever gel you want to call it, and I don't want to throw all of this away, so I've made this simple tool which hopefully works with 2 bearings. This is my tube squisher. Look, it's completely clean here, so I should just be able to pull on here. Tube squisher seems to be working, and now I can pour in a bit of resin to make this a bit thinner. I am introducing some air, so I also think that I have to pull a vacuum again. I think this consistency is a lot better. Let's put this on the vacuum, start printing again. Okay, I think I added a bit too much of the resin, so from this point onward everything went downhill. The tube didn't stay in place, so I had to redesign the tube holders on the in and outlet. Well, the pump had difficulties with this thick paste, so I tried to print really slow, but that didn't help. I tried a different nozzle, so I had to redesign the nozzle holder, and I added this 0.9mm nozzle, but that also didn't help. In the meantime, I destroyed this laser unit by touching it. The whole printer reset when I tried to power it back on. The laser, well, it's fried, and I think it's some static discharge, but normally it shouldn't be possible to destroy electronic devices by touching the casing, but well, yet here we are. This thing is destroyed. Then I tried to move the pump directly on top here to make the path a lot shorter from the pump to the nozzle, and I also made a cup holder so this tube can be a lot shorter. There was some air in there, and I could see that the pump itself was having difficulties pumping this thick resin. And to be honest, I'm at the point of giving up, but I really want to try one more time. I didn't want to print this out of resin again, it's just too much work. So I printed the version out of FDM. If this design doesn't work, then I'm going to call it quits. So I'm going to mount this to the printer, fingers crossed that it works. In the meantime, I want to thank my Patreon supporters, especially these guys. Your support helps a lot with these projects. Okay, let's see if it works. I'm giving up. This is... this is research. Okay, hold on. While I was editing this, I realized something. Even if the pump was so strong that it could pull a complete vacuum, then it still wouldn't work, because the gel is just too thick. Well, the force of the atmosphere isn't enough to push all the gel through. To test that hypothesis, I used my trusty tube squisher, and indeed it couldn't pull it all the way through. So there are two possibilities: or we have to put pressure on the vat, or we have to place the pump closer to the vat, the latter being a lot easier. So I put it directly on top of it. After a bit of tweaking, I got this. It works. It looks so freaking good. I was just about to give up, and here we are. This is so insane. Okay, let's print the Banshee out of resin on a standard FDM printer. I think that the real star of this show is this nozzle. It has just everything in one package. I'm very curious if it will manage to bridge gaps. I don't think it is. Shit. Ah nee, tyfus. I think that we have all ingredients here to get continuous fiber printing to work. This fumed silica has its advantages compared to the glass bubbles. The main advantage is that it completely dissolves in the resin, so it stays homogeneous, unlike the glass bubbles, but it cannot bridge gaps like the glass bubbles do, and so it's still not perfect. If you got some other suggestions, then leave a comment. I'm going to focus on some other projects first and let this sink in, and then we are going to pick this up quite soon. If you find this interesting, I think that you will also like this video, and if you want to see something totally different, then I suggest watching this one.